So we can see delta 1 here, it is PL upon AE, area is pi by 4, okay, pi by 4 d square, so it is 4 PL upon pi d square L, and delta 2. Here 4 is there, then the load is double, length is double, diameter is double, modulus of elasticity is double. So we are getting 4 PL upon 2 pi d square L. Now they ask the ratio d1 upon d2. So d1 upon d2 is what? It is 2. Is it clear? So is this tough question? And it was asked in gate mechanical. Okay, so it's one of the simple question. Okay, simple formula based question. Is it clear to everyone? Okay, let's move to next problem. This is good question. Try to solve this question, guys. So in this question was what they say, a tapered rod has diameter d1 at one end, which reduces uniformly to a diameter d2 over the length L. If the modulus of elasticity of the material is E, the change in length of the rod due to application of load P. Now what they are saying, a tapered rod has diameter d1. Now it is uniformly decreasing to a new diameter d2. Guys, this is one of the solved problem from Gare, and it is a gate problem. Okay, yeah, A is the answer, Prutesh. It is a solved problem from Gare. Okay, now here what they did, they are applying a load P. The length of this is L. They are asking what is the change in length. Okay, and this is standard formula also for tapered rod with uniformly change in area. We have to derive formula for what? Delta. Now guys, tell me, if I take any section which is at some distance, x, what is my diameter? What is my diameter? Anyone? How we can find? See, this change in diameter is uniform. This change in diameter is uniform. So I can write the initial diameter is what? D2. Then diameter is uniformly decreasing. It is uniformly decreasing, so minus sign. Okay. What is the total change? It is D2 minus D1. Okay. Over what length? XL length. Right. And at what distance we have to find? A distance x. Is it clear? How I found dx? How I found dx? Is it clear? See, the change is uniform, so I can write what is my initial diameter. Now change is what? It's a reducing, so negative change. So total change over what length and at what distance? You can derive also this formula. We can derive also, but this is the way to understand this. Is it clear? Anyone has any concern here? How I found diameter? Ankit, is it making sense? Gautam, I do not see any doubt from you. How is your preparation? Raman, now you got free from your campus work? Okay, please take from other end. How can I find? Now, if you take from this end, okay, other end also we can find out. Okay, suppose I take yeah. Hello guys. Now someone want from other end. Okay. So let me do that also. Let me completely solve this problem, Dinesh, and then we will do from other end also. Okay. And I will also make you understand how we can derive. Okay. Now once you got dx, now here since my area is varying, okay, so my delta will be in integral form and it will be 0 to L. My load is constant, so it is what? P dx upon area is varying, so it is ax. E is constant, material is same. Now what is your area? It is 0 to L. P area is pi by 4 dx square, so it is 4 p dx upon pi e dx square. Now guys, you know already dx. Substitute here, integrate it. Do it guys. I'll write further term. Is it clear till this point? So I can rub and I can do it further. Is it clear guys? Okay. Now, what is my delta? It is 0 to L 4p dx upon pi e dx square. And what was your dx? My dx is d2 minus d1 upon L into x. Now guys, here we guys know already what is the integration of 1 upon a minus bx power n. What is the integration of this guys? Anyone? It will be what? One moment guys, just a moment. What is the issue? Now what is the integration of this? Anyone? It is always 1 by minus b integration a minus bx power minus n plus 1 upon minus n plus 1. Am I correct? And the integration limit will be, suppose it is 0 to L, you can write 0 to L. Is it clear? Is this integration is clear? Okay, so what I have to do now, I will substitute this here. So what will be my equation? 0 to L 4p dx upon pi e, it is d2 minus d1 upon L into d into x. Is it clear? Is it clear? Now we can integrate. So what I will get? When I integrate, I'll get this 4p upon pi e is constant. B is what? This is what my b term. So I'll get, you'll multiply 1 upon minus d2 minus d1 upon L. Is it clear? Now it is whole square. Okay, it is a square term. So minus 2 plus 1 is how much? Minus 2 plus 1 is how much? It's a minus 1. So if you integrate, it will be what? 1 upon d2 minus d1 upon L into X. Okay, and this minus will become plus. 1 minus this minus and earlier minus became plus. So is it clear? Till here it is clear? Now this is integration from 0 to L. Okay, this is integrated from 0 to L. So what I'll get further, if I write my delta, it is 4p upon pi e. It is d2 minus d1. Okay, it will become 4pl. I have taken L on numerator. Now I will apply limit. When I applied the 0, this whole term will become 0. So I'll only get 1 upon d2. When I apply the limit L, this LL will get cancelled. So I'll get minus 1 upon d2 minus d2 plus d1. So what I'll get? Is it clear? Is this clear, guys? Now I'll rub everything. Okay. Now, anyone has any doubt here? Okay, so let me clear here what I'll get finally. Delta equal to 4pl upon pi e d2 minus d1, 1 upon d2 minus 1 upon d1. So what I'll get? 4pl upon pi e d2 minus d1. Now we can take LCM. When we can here take LCM. I think somewhere did I miss any negative positive sign? Okay, let me check what it is. D1 D2 take LCM, we'll get D1 minus D2. I think somewhere one negative sign is the, why this negative sign? Okay, yeah, yes. What I did mistake, the initial diameter is D1, but I have taken initial diameter as D2. Okay, that's why this is there. The initial diameter is D1. Okay, I have taken initial diameter as D2. Okay, so finally what we see, this term got cancelled with this term, and we get 4pl upon pi d1 d2. So what is the answer? A is the answer. No one told me the initial diameter is d1. So my dx should be what? My dx will be d1 minus d2 upon L into x. What I have written? If I remember, I written d2 minus d1 upon 2x. So clear now? The process is clear. Now if you see the solution of this question in Gare, they have done in bit complicated way. Okay. In Gare, same question is solved, but they have done little lengthier way. This is the easiest way. What is the? You find the diameter at any section, you integrate it, you will get this formula. Now, this formula is standard formula. Okay. We can always apply for a tapered bar if your diameters are uniformly changing over length L. For the applied load and load P, your deflection is what? 4PL upon pi E d1 d2. Is it clear? Because this we will use in next question. Okay, in gate question, we will use it as a standard formula. Clear? Is it clear? Okay. Now someone had this question. If I come from other side, how will I will write? So you are coming from other side at a distance x. Initial diameter is d2. The final diameter is d1. So what will be my dx? It will be d2 plus diameter is increasing. What is the change? The change is d1 minus d2. Okay. And over what length? L. At what distance? X. Hines, is it clear? Okay. Now someone will ask how we can derive it. So if you want to derive, then what you have to do? See, it can be done by some triangle property. You can see my inner part has diameter d2. My outer part, the total, this distance is what? d1. So what will be this distance and this distance? It will be d1 minus d2 by. Is it clear? Is it clear? Okay. Now at any section this, suppose I am coming from this side. At this section, what will be this length? What will be this length? Suppose it is some length bx. So what will be bx? It will be dx by x is equal to d1 minus d2 by 2l. So what will be your bx? It will be d1 minus d2 upon 2l into x. Okay. Now at any section dx, what is your diameter? Dx is nothing but d2 plus 2bx. Is it clear? We got the same formula previously also. d2 plus d1 minus d2 by l into x. So same thing, 2 is cancelling. We are getting the same formula. I think it's clear. It's clear to all. Okay. So let's move to next problem. Yeah, this is the problem I was talking. Guys, try to solve this problem. And here we can use the directly formula for this section. As my delta is what for this section? Suppose it is a delta, so it will be 4PL upon pi d1 d2. Since it's a prismatic section, this is a uniform section, so my delta 2 will be what? PL upon 4PL upon pi d2 square. So everything is given. Find out delta 1 and delta 2. Now tell me guys, for this problem, what is the reaction throughout this section 1 and section 2? Is your reaction force changing? Is reaction force changing? No. Why no? Because there is no intermediate load, no intermittent or intermediate load. So throughout, if you take any section, your reaction is P itself. That's why I written delta 1 is what? 4PL upon pi d1 d2, and delta 2 is what? 4PL pi d2 square. Now E is same, d1 is given, d2 is given, lengths are known. So suppose this is length L1 and this is length L2. L1 is 2 meter, L2 is 1.5 meter. Guys, solve this problem. Find out total deflection at point A. So what will be delta A? My delta A will be delta 1 plus delta 2. P is given as 30 pi kilonewton. Yeah, 15 mm is correct answer. So guys, find delta 1 first. So from here, now guys, remember it. Dimensions should, you can convert dimensions in mm. Okay. So here I am missing here pi. Okay, E. Here also E should be there. Okay, 4PL upon pi d1 d2 E, and here also E will be there. So convert all the dimensions are in mm. So what it is? 4 into 30 pi into 10 to the power 3. Now length is 2000 2 meter. So 2000 mm upon pi into 20 into 10 into 2 into 10 to the power 5. What is this? It is 4 into 30 pi into 10 to the power 3 into length is 1500 upon pi into 10 square into 2 into 10 to the power 5. Is it clear? Delta 1 and delta 2? Yeah, 15 mm should be the answer. I have written everything. Please find out delta 1 guys, and please find delta 2. Is it visible to everyone? Whatever I have written? So everyone got it? Anyone has any doubt here? Salva, how is preparation? Steve. So guys, have you solved assignments? Please complete all the assignments. Okay, and write exams. You guys are writing exams. Now, since the registration has been started, so keep few things in mind. Yeah, 6 plus 9, so 15 is the answer. So keep few things in mind. Those who are fourth year students and passing engineering or passed engineering, they must write two exam. Either it is a mechanical guy or aero guy. They can write gate ME plus gate XE or gate AE plus gate XE. The advantage is that it will help those guys for further interview preparation. In gate XE, they can choose two paper, either fluid plus thermo, fluid plus solid mechanics, or solid mechanics plus thermodynamics. So anyway, when you go for any master's interview, you will be specific to one area, either fluid side or thermo side or solid mechanics. So that is the advantage. Another advantage, if you want to pursue masters, uh, that gate score will be helpful. Gate XE gate score. Okay, and gate XE questions are quite good. Any of the question you take. Okay, so I request all of you must write, because after that you may not get that chance, to again opt two paper. uh, I mean, after submitting application form. And second thing, whoever has category, please submit your category detail properly. Because I have seen the last year few people has not applied for EWS, general category people in economically weaker section. So they must use their category. It is helpful, as I told in the previous class also. People get benefit out of that. Okay. So now come to the, yeah, what about third year student? Third year student, I suggest they must focus on only one paper, and that is their mother stream paper. Okay. Do not get too much of deviation, but if you are confident, third year students like mechanical students, anyway, they are learning, solid mechanics, thermodynamics, and fluid mechanics in depth. They can write gate XE also. Sanyukt you can write, or any other students, mechanical students, be free to write. Aero guys, third year student will have constraint, uh, because they have not learned many of the core things. So I suggest them to write one paper. You guys can see, feeling second paper is not an issue, but preparing sincerely, it will be a challenge for aero guys, especially. For mechanical guys, it won't be, because they are learning all these subjects in a proper way. Okay. All right. So let's go to next problem. Yeah. So this is from Gate Mechanical, and I think in Gate 2018 they asked this problem. Gate 2018. So what is the problem? They read the problem. What they say? A horizontal bar fixed at one end has length of 1 meter and cross-sectional area of 100 square. Its elastic modulus varies along its length, given by E equal to 100 e power minus x gigapascal, where x is the length coordinate along the axis of the bar. An axial tensile load of 10 kilonewton is applied at the free end x equal to 1 meter. The axial displacement of free end is. So what is the question? There is one uniform cross section bar with end load P equal to 10 kilonewton, The length L equal to 1 meter. Now what is the varying here? Your material property E is the varying. Okay, E is the varying quantity, and what it is? It is 100 e power minus x gigapascal. Now whenever we have told, whenever anything is varying, either load, material property or cross section, my delta will be in what? And it will be in integral form. So it is 0 to L P dx upon A ex. Now one thing here, guys, tell me, will you integrate this in mm or meter? Which will you will prefer? You'll you'll Yeah, 1.718 I think is the answer. Will you integrate from 0 to 1 or 0 to 1000? In this question only the issue is that only. No. If you integrate in meter, you will not get answer. Okay, yeah, I think in meter you will get answer. In if you integrate, you will not get answer. Okay, you have to integrate it to 0 to 1. Okay, because and just do it. Let's do this integration. What you'll get? T is constant, area is constant. I can take out. So it is integrated 0 to L dx upon 100 e power minus x. Now gigapascal. Okay, so if I convert everything in megapascal, then I have to multiply it by 10 to the power 3. But okay, so let's do one time. Convert everything in megapascal. So if you multiply 10 to the power 3, so then what will happen? The limit of integration will be 0 to 1000, and you will get finally P upon 100. So it is area into 10 to the power 5 integration 0 to 1000 e power x dx. Now e power 1000 you cannot solve. What happened? E power 1000 will not give you any value. Okay, because finally when integrate, it will be what? E to the power x. Integration is what? E to the power x. So you will get, if you write here, my integration will come like this: e to the power 1000 minus e to the power 0. Okay, e to the power 1000 is not defined. So what you have to do? You have to integrate instead 0 to 1, then everything you convert it in Newton per meter. You convert everything in Newton per meter square. So do that and find out the solution, find out the answer. Or let me do here. So my delta will be what? It is yeah, area is given, right? So it is P by A. Okay, and I'm converting in Newton per meter square, so it is 10 to the power 9 integration 0 to 1 upon 100 e power minus x dx. So it is 10 into 10 to the power 3 upon 100 into 10 to the power minus 6 into 100 into 10 to the power 9 integration e to the power x 0 to 1. Is it clear? It is correct? Is it correct, guys? So this will get cancelled. So we'll get 1 upon 10 to the power 3 e power 1 minus 0. Sorry, e power 0. So it is what? 1 upon 10 to the power 3. E power 1 is how much? 2.718 minus 1 meter. So it is in meter. So 1 upon 10 to the power 3 meter is what? Mm. So answer is how much? 1.718 mm. Is it clear? Is it clear? So you guys understood the importance. What is the trick here? What is the trick? We have habit to convert everything in mm, right? Integration. Okay. So there we have to be careful. Okay. In gate exam also, if you get puzzled like that, you have to change in other dimensions, especially if in your area, material, or anywhere, if it is a function of e, if it is a function of e, then please change your integration to meter unit. Okay, please change your integration to meter unit if it is a function of exponential. Clear? So let's move to next problem. Now the next problem is stepped shaft. Okay, but in this case, what they asked? In this case, they asked what strain energy, I think. Yeah, strain energy. What they asked? Strain energy stored in the structure. Now we know for a stepped shaft, what is my strain energy stored? My strain energy ES is what? Sigma Ni square Li upon 2 AIEI. Now here, what is the Ni? Is it equal to P or it is changing? My reaction, if you take section 1 or section 1, 2, what is your reaction? N1 is equal to N2 is equal to P because there is no intermittent load, right? So that is what. Now E1 is different, A1 is different, your E1, A1 is different. Okay, E1, A1 is different, A2, E2 is different. So we can write everything is given, L1 is given, L2 is given. So just write it and find out. So it is P square L1 upon 2A1 E1 plus P square L2 upon 2A2 E2. Please find strain energy and they are given it in Newton mm. Find it in Newton mm. Please guys do it. Hello. No, I'm not speaking. I didn't say anything. I was just writing. Okay. So, what is the answer? 35 Newton mm. Now you guys can see what I did. I substituted everything. What is my load? It is 1 kilonewton. So it is 10 to the power 3 Newton. I have taken P square outside. So it is 10 to the power 6. Now what is the length L1? 400. What is the area? 100. E1 2 into this. Now E2 is what? 3. So it is here 3, not 2. Now what is the length L2? 900. Area 60. E is what? 3 into 10 to the power 5 mega Pascal. So megapascal is what? 1 Newton per meter and 1 Newton per mm square. We know what is 1 megapascal, guys? 1 megapascal is what? 1 Newton per mm square. Is it clear? Is it clear? Okay, so everyone got this answer? 35 Newton mm. Any concern here? Is it tough question? Most of you will be knowing what is the bar, okay? How find deflection and everything. But many may miss this strain energy part. Many may miss strain energy part, okay? So sometime in your, if you take GATE aerospace, they asked only one time question from bar or rod in deflection, and they directly asked from what? Strain energy part, okay? So this is important. One more question, one more kind of questions they have asked. I think I have kept here or not. One question was good actually. I think I have not kept in this. I will solve maybe next class. Okay, so fine. Anyone has any doubt here? Okay, so let's move to next problem. Yeah, this is one kind of problem they ask in GATE. Okay, they have asked one more similar problem. Okay, I'll see and I'll draw that problem at the end of this. Okay, we'll do that as well. Okay, so look here what they have given. As shown in the figure, the link AB and CD, this is the AB and CD, support the rigid member BD. This is my rigid member. Link AB and CD are made of aluminum alloy. Each has cross-sectional area of 100 mm square. All the members are pin connected and all the dimensions are in mm. Neglecting the weight of the member, the elongation of the link AB is. What they asked? They asked the elongation in link AB. Now, what is the rigid link, guys? What is the rigid link? What is the rigid link? In rigid link means there is no deformation, right? So that means when this load is applied like this here, it may in new position it may deform like this. Means one link AB may have this kind of deformation and this may have this like this, or it may have reverse also. What I mean, it may have like this also. in the new position. Okay. So now how we can solve this problem? This is the initial, this is the final position, this is the initial, this is the final position. To solve this problem, what we can do, anyone has any idea how we can solve this problem? No, link will deform. These link AB and CD will deform because they didn't say this is the rigid. Rigid is what? Only BD is rigid. Okay, exactly. What we can find? We can find reactions, exactly. But how you will find the reaction? I think Sayunk, the answer may be 0.04. I'm not sure. I don't remember. Now what we can do always in such problem, since here it is a hinge support, right? B and D is a hinge support. So we can make a cut at B and D. When we make a cut, what we have to do? We have to draw free body diagram. So let's draw here free body diagram when you make a cut at B and D. So let's make a cut at B and D. You will see this is what my link BD. So this is my B and this is my D. Suppose here my reactions I am taking, it is upward, and here there is a load applied which is downward. It is how much? 6 kilonewton. Now other part, if you draw, it will be like this. There will be a opposite reaction here at B, and same way this is what my C, there is here a opposite reaction, okay, which is at D. Suppose this is R1, this is R2, so this will be R1, this is, sorry, it is in opposite downward direction, okay, and it is R2. Is it clear? Is this clear? Is this clear, guys? What I did, I made a cut and I drawn free body. So when you apply here at one reaction upward, of course it is in balancing, there will be a downward, okay, opposite force. Here it is upward, so there is a downward force. Now what we can do, now we can solve this. How we can solve? We can take moment equilibrium either at point D or at point B. We can take moment equilibrium at point B or point D. So what it is? Sigma MD is 0 or sigma MB is 0. Now do sigma MD is 0. So what it will be? R1 into 300 will be equal to what? 6 into 10 to the power 3 into 200. Now tell me, guys, what will be your R1? What is your R1? Is it clear how I took this? See, R1 is going upward. R1 is going upward, so about point D it will give a clockwise moment, which is what? R1 into this length 300. Now this is going downward, 6 kilonewton is going downward, this length is 200. So this load about D point will give anti-clockwise, so it is 6 into 10 to the power 3 into 200. So R1 is coming as 4 kilonewton. Now guys, R1 once you know, I can find delta AB. What will be delta AB? R1 L upon AE. Now length is given 400, areas are given as 100, E is given as 100 gigapascal. Please find out delta AB. So what it will be? 4 into 10 to the power 3 into 400 divide by area. It is 100 into 100 into 10 to the power 3. Okay, so you guys got 0.16 mm. Now you guys know delta AB. Suppose they ask what will be delta CD. So delta CD will be nothing but R2 LCD upon A into E. Is it clear? Is it clear to everyone? Okay, that's good. That's good. So this kind of problem we can solve like this. Delta, sir didn't get delta AB. See, delta AB is what? Whatever deflection in this, how it will deflect due to this reaction R1, right? This AB will deflect due to reaction R1. And when we know this is the fixed end and this is the free end, what is my deflection? It is PL upon AE. What is P? P is R1. Is this clear, Kateshwari? Yeah, delta CD is 0.08 mm. Yeah, they didn't ask in GATE exam, but we can find. So that means if I see the finally it is deflecting like this. Is it clear? Finally it is deflecting like this. Okay. Now let's see the problem number 9th. What is the problem number 9th? A circular rod of length L and area of cross section A has modulus of elasticity E and coefficient of thermal expansion alpha. One end of the rod is fixed, other end is free. If the temperature of the rod is increased by delta T. So what will be your stress? Your stress will be 0, but your strain will be non-zero. So stress developed in the rod is 0, strain developed in the rod is alpha delta T. Clear? But if delta T is non-uniform, okay, now in this case it is uniform because they used this, the rod. The rod means this complete rod got temperature got increased by delta T. If they say, they do not say this word here, that means your delta T can be non-uniform. Okay. So the answer is what? Answer is C. Clear? Now some people will say again Hooke's law, right? So if strain is alpha delta T, how strain can be non-zero? Actually, as I told, Hooke's law is only applicable for mechanical loading. It is not coming in picture for thermal loading. Okay, clear? Is this clear? Now look question number 10th. Look into question number 10th. What it says, An elastic bar of length L, uniform cross-sectional area A, coefficient of thermal expansion alpha, Young's modulus E, fixed at two ends. The temperature of bar is increased by T, resulting in axial stress sigma. Keeping all the parameters same, if length is doubled, what will be axial stress? So what is your axial stress when length is L due to temperature delta T? Anyone? What is sigma x thermal? It is minus E alpha delta T. Now tell, is it depending on length? Is it depending on length? No. So even length is doubled. Even length is doubled. What will be your sigma xt? This is T1, this is 2. It will remain minus E alpha delta T. So what is the answer? A is the clear? Is it clear? Okay. Anyone? Any concern here? So let's move to next problem. Read, this is good problem. Only the language is bit tricky. Read the problem. What it says? At a temperature of 40 degree, a rod tightly fits between two rigid walls such that compressive stress in the rod is 60 megapascal. E equal to 200 gigapascal, alpha equal to 20 into 10 to the power minus 6. Find the temperature at which rod will just lose contact with the walls. Find the temperature at which the rod will lose just contact with the walls. So I am assuming the initially temperature was T naught, at which my stress is 0. Stress is 0 when rod is not in contact. Okay. So at that point your stress is 0. Yeah guys, so when initial temperature T naught, your stress is 0. Now this T naught, suppose it became T1. Okay, so your stress is how much? It is 60 megapascal. Okay, clear? Now the stress is compressive, right? Because we know always sigma x thermal is what? Minus E alpha delta T. Now what is your delta T here? Delta T is what? T1 minus T naught. Now what is given? T1 is given, T naught is unknown. What is given? At 40-degree temperature, your stress is 60 megapascal. So at T naught, it is 0. So find out guys T naught, how you can find out? Minus 60 megapascal, right? So it is minus 60 is equal to minus 200 into 10 to the power 3. Alpha is given as 20 into 10 to the power minus 6 and delta T, right? So delta T is what? 40 minus, sorry, 40 minus T naught. Find out T naught guys. Find out T naught here. Yeah, that's the correct answer. That's the correct answer. Is it clear? Is it clear guys? Anyone has any concern here? Solve this. Your T naught will come as 25 degree centigrade. Okay, so let's move to next problem. So we have done this concept in last class. Now guys, read this problem, what it says. A circular metallic rod of length 250 mm is placed between two rigid immovable walls as shown in the figure. The rod is in perfect contact with the wall on the left side and there is a gap of 0.2 mm between the rod and the wall on the right side. If the temperature of the rod is increased by 200 degrees centigrade, the axial stress developed in the rod is. Now guys, tell me here, axial stress they asked. So in answer, will you write positive or negative? Will you write positive or negative? You must write negative. You must write negative. Why negative? Axial stress can be positive or it can be negative. If they say what is your compressive stress, then you write positive answer. Or if they say magnitude of your axial stress, then only you write positive sign. Otherwise, we have derived in last class what will be your sigma x thermal. It will be minus, right? And it is what? Delta T. So delta T is what? It is alpha delta T into L naught minus delta gap, right, upon it was L naught plus delta gap into E. Am I correct? This is the formula. I can write again. What is my formula? Whenever there is a gap, my formula is what? Sigma x thermal will be minus, it is alpha delta T L naught minus delta gap upon L naught plus delta gap into E. Guys, substitute and find the answer in megapascal. Everything is given. The L naught is 250 mm, delta G is 0.2, alpha is 10 to the power minus 5, and E is 200 gigapascal. Find out the answer, guys. So it is 10 to the power minus 5. Change in temperature is 200. It is 250 minus 0.2 upon length is 250 plus 0.2 into 200 into 10 to the power 3. Yeah, it is close to 240 megapascal. So it is minus 240 megapascal. Closely 240, or it is exactly, if you write exactly, it is 238 239.8 megapascal. So what the answer? In fill in the blanks, what we will write? In fill in the blank, you will write minus 239.8. Why minus sign? Because they didn't ask any particular compressive or tensile or magnitude. They asked it as just axial stress. In GATE exam, they are very particular about sign. They are very particular about sign. So this question is from GATE ME. In GATE mechanical, they ask more questions from thermal stresses of bar part. Okay. In fact, few more questions they have asked. Is it clear? Is this clear? Anyone has any doubt here? Because yesterday we derived this formula. Everyone, we have derived this formula here, I think here, not here, before that, right? Where we have derived formula? Yeah, before that. Yeah, here. Yeah, so this is done. Now let's see the next problem. What problem says? A 200 mm long stress-free rod at room temperature is held between two immovable rigid walls. The temperature of the rod is uniformly raised by 250 degree centigrade. If Young's modulus and coefficient of thermal expansion are 200 gigapascal and 1 into 10 to the power minus 5 per degree centigrade respectively. Magnitude of longitudinal stress developed in the rod is. So now again tell me, my thermal the longitudinal stress, right, which is thermal stress, it will be plus or minus. Why plus? They just asked longitudinal stress. They didn't ask it has to be negative. It has to be negative. They didn't, sorry, they asked magnitude. So that means the value should be positive. Okay, when we substitute here, the value should be positive. They asked magnitude. Okay, whenever they asked magnitude, you must provide positive answer. Okay, you should not put negative. So this is what my sigma x, but my magnitude will be what? My magnitude will be mode of sigma x thermal. So it is E alpha delta T. Find out, guys. E is given, alpha is given, delta T is given. Now someone will ask, what is the use of length here? What is the use of length here in this problem? What is the use of length here? It is just for beauty of the problem. Both the ends are fixed. Okay. Length is L. Even length is 500, 400 also. Here it is 200. I'm saying even if it is 500, 400 also, your thermal stress will not change. Okay, so what is the answer here? 500 megapascal. So answer has to be positive here. Answer has to be positive. Why positive? Because they asked magnitude. Why answer is positive here? They asked magnitude. Is it clear? Anyone? Sanjita, are you solving questions? Rohan, Ravi Shekhar, you recently joined. Are you understanding? Sikha, how is the progress? You were there, right? I think she is not there now. Okay. So shall we move to next problem? Let's look into next problem. This is again a similar problem. What it is given? A steel bar is held between two fixed supports shown in the figure, is subjected to an increased temperature delta T. If the coefficient of thermal expansion and Young's modulus of elasticity of steel are 11 into 10 to the power minus 6 per degree and 200 gigapascal respectively, magnitude, again magnitude of thermal stress induced in the bar. So what is the magnitude of thermal stress? It is mode of sigma x thermal. It is minus E alpha delta T is nothing but E alpha delta T. So find out the answer. It is E is 200. So it is 200 into 10 to the power 3. Alpha is 11 into minus 6 and into 100. So 222 megapascal. Okay, so I think all these problems are done. We will take one problem from 2019 paper. Okay, so So one problem I will share in your WhatsApp group, and you guys will able to see the problem, and same problem I will write here as well. Okay, yeah, I'll share in WhatsApp group so you guys can have a look. Okay, so let me write that problem where I have more space. I think here I have enough space. Okay, let me. Yeah, hello guys. Sir, the mock test of bar is same as what we are doing. No, mock test is different, na? There is a separate exam, right, for mock bar. Means in portal there is exam. Yeah, topic is same. Whatever we have discussed is there in our, mock exam. I have covered all the concepts which are there in mock exam. Now look into this problem, guys. Look into this problem. Hello. Yeah, yeah. Can I call you in after some time? Yeah, sure. Thank you. Yeah. So is it visible, guys? Is it visible? What is there? There is one rigid link CD is connected by three cables. One cable outer, two outer cable, and one inner cable. The total weight of this rigid link is what? W. The total weight of this rigid link is what? W. Now they ask the percentage of the weight carried by central cable. The percentage of the weight carried by central cable. Central cable will carry 100% weight. Others. How we can solve this problem? I think 60 is the correct answer. Okay, so how we can solve, guys? We can solve this way. In this case, the deflection will be same. I will have, see how we can solve. If you break it, you will have one RC, there is a middle reaction R, and this is RD. Now since it's a uniform, right, it's a symmetry, so RC will be equal to RD. RC will be equal to RD. So my and this total weight is how much? W. So what will be your equilibrium equation? 2RC plus R is equal to W. Am I correct? What they asked, what is the value of R in terms of the W? Am I correct? Now this is the one equation. What will be other equation? See, this is the rigid link. It will move together because it's a symmetry, right? Due to symmetry, whatever deflection in middle cable will be equal to in outer cables. So what I mean, your delta 1 will be equal to delta 2 equal to delta 3. Delta 1 and delta 3 are outer cable. Delta 2 is what? Middle cable. Is it clear? Is it clear, guys? What is your delta 1? Your delta 1 is what? RC into L upon E into A. Now, the length are same, areas are same. What will be your delta 2? My delta 2 is what? R into L upon 3EA. It is what? 3EA. So what will be your R in terms of RC? Or RC will be what? R by 3. Am I correct? RC is what? R by 3. Is it clear or not, guys? Now substitute this RC in this equation. Substitute there. So what I will get? I'll get 2 by 3 plus 1 into R is equal to W. Am I correct? So R will be what? From here, R will be 3 by 5 W. So that means what? Middle one will carry 60% of the weight. It is what? 0.6 times W. Is it clear? So this problem was in GATE 2019 and it was asked for 2 marks. Is it clear? Anyone? Can I need to explain again? Okay, again I'll write here the problem in the last. What is the problem? You have 3 identical cables. 3 identical cables means the length are same, areas are same, but your E value is different. So the outer one has E, inner one has 3E. Now here there is one link, rigid link, and weight of this rigid link is what? W. Now since it's a symmetry, right, so it will go down. The load is distributed uniformly, so all 3 will have the same deflection. Okay, so sir, in this case, if it in equilibrium the outer cables are cut, the weight will oscillate. No, weight will be balanced. Okay, but your deflection will be much more. It will not oscillate till you disturb. Okay, till you disturb it, it will not oscillate. it is like that something is hanging from CG. Okay, and both side your load is same. So what we saw here, delta 1 is equal to delta 2 is equal to delta 3, and we know delta 1 is what? RCL upon AE is equal to RL upon 3AE. And another condition is what? 2RC plus R is equal to W. How 2RC? Because your RC and RD will be same. As both has same material. Okay, so any doubt? I thought to start the next topic, but now only 20 minutes are there. So we will not start new topic. We will take next torsion of shaft in next class. I can take up some doubts. Do you guys have any doubt? Any doubt? Sir, I solved it by dividing central cable Young modulus by E multiplied. I define any moment or reaction. Is it acceptable? I didn't get what you did. Total E multiplied by 100. I didn't understand what you told. Okay, you did Sanyukta this way, right? 3 is total is 5E into 100. You got this way, this logic 60%, but I am not sure how long this is correct. Here it is correct. Here it is correct. I think in this case we can do it because so the load is acting uniformly. And outer cables are having the same material. If outer cables are not having same material, then what will happen? If outer cables are not having same material, then we have to take, moment, equilibrium and all. Yeah, length is same. On top of that, material is same. Okay, so that's why this may be correct.